Ugh.
Hey,
Yuck.
bud.
Yuck.
What's happening?
Nobody wants to listen to a podcast now. Everybody just wants to go find a rhinoceros to punch in the face.
Don't punch rhinoceri. That's extremely rude.
That's true. Don't do that.
They're endangered. Leave them alone.
Okay.
Or if anything, like help them out.
Punch through something more with less feelings, but equally sturdy. Yeah, I mean,
Don't punch stuff. Just listen to our podcast about weird rocks in outer space.
and our bangers.
Yeah, that's fine. You can listen to our music too. But for now, listen to our podcast about weird rocks from outer space.
Look, I'm not saying it was aliens, but it was aliens. What's up, man?
I'm chilling.
Are you chilling?
Yeah.
Like a villain in your crib?
Sure.
The things around these parts, they haven't changed.
Pardon?
I froze to death all day. Did you test it out there? It's not good.
It's very unpleasant.
It's extremely unpleasant.
Yeah, it's winter. Whatever.
You guys, if you're new to the show, Spencer and I live in Minnesota, and oh boy, Minnesota happened overnight, it feels like. I
It
struggled.
always does.
I struggled today. I didn't wear long johns. I done goofed. I goofed hard. I wore my parka. I'm a dumbass, bro. I needed my long johns, and I didn't do it.
Dude, that sound is going to get so much use tonight.
Do you guys know why? Because we're stupid.
I'm a dumbass.
We're going to try and talk about science.
Science and space are very hard things to talk about as people who are neither scientists nor space scientists.
No, none of those things. Well, one of those isn't a thing, but we definitely did not get any PhDs in physics or astronomy or astrobiology or
Computer science.
literally anything.
Literally anything, but
We don't even have
especially the things that are related to what we're
We
talking
have
about.
0 graduate degrees combined.
But you know what, guys? Between the two of us, we've got 8 years of public education and 8 years of public collegiate education, and we'll be goddamned if we don't make up a bunch of shit today.
Wait, we only went to school for 8 years total?
I meant 8 years combined high school,
We both finished
public
the 4th
school.
grade and went straight to college.
What you guys
I'm a dumbass.
What you guys didn't know is that Spencer and I's episode 1 we recorded when we were both 12 in the 5th grade.
Correct.
We said we're dropping out of
Also,
school.
we got held back a year for 12 in the 5th grade.
We said we're dropping out of school and we're going to talk about aliens.
So, shall we?
I mean,
I don't think we have any relevant voicemails or anything this week. Let's just talk about weird space rocks that might be aliens.
I'm here for it, man. Well, these are weird space rocks we talked about once before, very briefly on the paid show. So for those who don't know, we do 2 episodes a week. If you go to patreon.com/whatifpodcast, you can hear the second episode every week for just $5 a month. But we talked about this when it hit the news super briefly a long time ago, being like, that's weird. I think we probably had significantly less scientific understanding of what it was when it first hit the news.
The it in question being Oumuamua,
Oumuamua.
the asteroid or rock or alien spaceship, depending on who you ask.
Ew.
That came through our solar system in October of last year. So
Yes.
just over a year ago.
Yep.
It was first observed October 19th of 2017 by astronomers at the University of Hawaii. And it was named Oumuamua after they consulted with a Hawaiian linguist.
Cheers.
Oumuamua means either scout or, in a slightly longer version, messenger from the distant past reaching out to us.
Feel like scout appears to be a dramatic oversimplification of the content of that word.
Yeah.
Sounds why you being lazy, my boy.
Why are you being so lazy, my boy? Come on, man.
Thank
It was
you.
first, it was
Thank you.
discovered by Robert Work. I think that's how you say his last name at the Haleakala Observatory in Hawaii. Hawaii. It was before it was named Oumuamua. It was actually briefly named, or they were calling it Rama, as in Rendezvous with Rama, the Arthur C. Clarke book.
Oh, I missed that.
Are you familiar with that book or the the gist of that book?
I am not actually. That's all new information to me.
Well, it is relevant to what we're going to talk about because Rama in the book is the name of an alien spaceship, originally mistaken as an asteroid.
Oh.
It's detected by astronomers in the year 2131 while in the orbit or near the orbit of Jupiter.
I gotta say, I think there's something interesting about the fact that nerdy space science people, upon its initial observation, chose to call this thing something like that.
Mm-hmm. Also, Arthur C. Clarke was really smart and right about a lot of stuff.
Yeah.
Like correct about a lot of stuff.
I just think, we'll get into all of this later, but I think it's evidentiary of the way that it was initially perceived by people who are trained and educated in perceiving these types of things.
Yeah.
They were like, something's not right here. This ain't day to day.
So yeah, in Rendezvous with Rama, there's an asteroid that comes from outside of our solar system that turns out to be an alien spaceship.
Sick.
And people go meet up with it and see what's up.
Like meet up with it like they go do the old Armageddon thing.
They ride some like cool space bikes out there and
bikes?
I don't want to ruin it for anybody. It's a good book.
Okay.
Rama is also a Hindu god, apparently.
Okay.
Anyway, Oumuamua came through our solar system from outside of our solar system, which is the first time that we have observed anything doing just that.
Yeah, and actually, I think before it was called Rama, it was called 1I/2017U1.
Tight.
Which
I prefer Oumuamua.
I do too, or Rama. But the interesting part of that I found to be kind of cool is that we use A in the place of the I that I stated normally in that sort of designation of these types of things because A stands for asteroid. And asteroids primarily are from inside of our solar system, and we change that A to an I for interstellar, as in from outside of it. So it's the first time that we actually use that because it's known that things from outside of our solar system can and have come through our solar system. But this is the first time, to your point, that we've actually seen it and documented it and been able to track it. So it's the first time we've ever had to label one with an I instead of an A.
So it was first observed October 19th of 2017 and last observed January 2nd of 2018.
Now,
so we had like 2.5 months or something to look at.
Did you find information about this? Because I'm confused about one of the things I saw said we could see it with telescopes for only 3 days. And what I was wondering was it that...
Where'd you see that?
In one of the articles I have. I'd have to pull up the part in which one. But I was wondering if there's an element of it where it was only observable from like an actual... like with the naked eye for 3 days, but then we were using other types of microscopes going forward after that to still keep track of it. Telescopes, thank you.
I'm a dumbass.
Here we go. Let's do it. Oh, it's gonna be so unfair because you get to hit it every time I say something dumb.
If you want a point, go for it. I'll try and be honest with myself too. If I do any dumbassery.
You're a dumbass, and then you have to hit it.
That's fair. Great. I did not read anywhere that it was only observed for 3 days, so I guess I can't really speak to that.
Okay, I'll see if I can find the reference to it. But keep going.
I know it was hard to observe because of how fast it was moving, and because of the shape of it, it was not reflecting light consistently. It's really elongated, so it's like 10 times. It has a 10-to-1 width to height ratio.
It's 1,300 feet long?
2,600.
2,600 feet
2,600 feet long by 260 feet wide.
I think I might have done my math wrong there. I'm a dumbass.
You had it exactly half.
Exactly half?
Yeah. I think that's an estimate, though, based on light it was reflecting. So they were trying to... It was reflecting light... I guess inconsistently or like in a pattern.
Yeah.
So when the long side of it was facing us / the sun, it would reflect more light, and then when it would get to the 260 foot wide end, it would reflect less light.
Right.
Because this thing, as it's moving through space, is also tumbling, so it's moving like around both axes.
Oh, it is. Okay.
Yeah.
Got it. I was also trying to find more info on that because I know it's like you said, rotating, but I didn't know if it was rotating along its I guess vertical axes, and if it was also rotating along its horizontal axes.
The whole thing is cattywampus. It's just tumbling.
The whole spaceship's cocked, boys. It ain't going great.
I don't know if I still have those on here anymore.
I gotta say, do you know what would suck a bunch is being inside of that as it tumbles head over feet, over head over feet.
Shit went bad real quick.
Yeah, fucking A. It's like that ride at the county fairs that you can get on that has the little cage. No. The one that like
it just spins the shit out of you.
Yeah, and there's just a little cage, little like jelly bean things on both ends. And
jelly bean things.
You know, they're like little pods.
I thought I knew what you were talking about until you said jelly bean pods. Now
they're like little oval pods where you strap into the oval pod. It's got the wire mesh on the sides and
Yeah. So anyway, we had this thing was in our solar system. Well, observed in our solar system over a period of about 6 weeks or so. But it probably came inside our solar system. Entered our...
Yep. It's both are good. Just go for it.
Entered our solar system around 1837 is the guess.
What? Damn.
I think the reason it recently became observable is because it was close enough to the sun to start reflecting light that we could see.
Okay.
But I could be wrong about that.
Okay.
I'm a dumbass.
There it is.
I know you didn't call for it, but I'm just trying to, honor system here.
Trying to play the part, you know, where it makes sense.
Any other crucial information about what this thing is, what it looks like, where it came from? Before we start talking about why it's fucking weird.
I think one of the things that I found very interesting is that it is traveling through our solar system at speeds of 196,000 miles an hour.
That sounds like a lot. Is that a lot in space terms?
I mean, we don't have a good, what is a lot in space other than what we do in our own
let me rephrase.
Yes.
Could we launch a thing that could catch it?
So, well, we can get into this now or we can get into it later, but there was actually a standardized organizational conversation around this exact concept.
So I'm going to guess that means it's hypothetically possible?
I guess hypothetically, yes. But I don't know. But essentially, right around the time that it happened, the Initiative for Interstellar Studies launched a project called Project Lyra, which was actually them bringing a bunch of smart people into a room and asking the question, could this ostensibly be feasible for us to send something to this thing to go check it out better or more thoroughly. As far as I'm aware, as far as I was able to read, it was just conceptual and hypothetical, but there is no ongoing plan to try to do this.
Right. Okay. So it's moving fast, but not faster than had we known in advance, we could have made something to catch up with it.
Right. I mean, for comparison's sake, the International Space Station is flying around our planet at roughly 17,000 miles per hour.
And you said this thing was moving at 196?
195, yeah. Okay. So literally 10 times faster than the stuff that's flinging around our planet 4.7 miles per second.
I wanted to look at Voyager to see if I can figure out how fast that thing is going now.
Yeah, that's a good question too.
But I might have to do math.
Uh-oh.
17 kilometers per second.
Uh-oh.
Ooh.
I've got an MPH for Voyager 1.
Do you?
38,610 miles per hour.
Okay.
So almost exactly 5 times as fast as our fastest probe that we're capable of creating.
Well, that we launched in the 70s.
Yes, that is currently functioning out there.
Okay. Why is this thing weird?
Well, for many reasons.
Okay.
The speed one is a place to start. That's part of the reason I kind of brought it up at this point. He's moving very, 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 very fast.
Is it moving very, 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 very fast relative to comets and asteroids?
Yes.
Okay. Then that's weird.
Which is weird. And also, so one of the things I found really interesting is there's this process through which comets and asteroids are actually known to accelerate over their lifetime. And I can't remember what the word for it is, but essentially they're made of rock and ice, and there's all this gas trapped in the rock and ice.
Is off-gassing perhaps what you're looking for?
Off-gassing is the word I'm looking for. And as these asteroids hurtle at these incredible speeds, these gases can combust, which actually add to their speed and their trajectory. But also it creates this kind of shrouded, like cape-like effect because it's combusting, off the back end of it as it's hurtling through space. And one of the additionally weird parts about Oumuamua was that it wasn't actually showing visible signs of that type of off-gassing.
Yeah. And it's not just the speed that it's moving, it's that it's displaying, based on some limited observations, but appears to be displaying non-gravitational motion, meaning that something other than just gravity is directing its
course,
acceleration and course.
Yeah.
A common cause of that is off-gassing, which you were just explaining. As in, like, passes by the sun. It's usually ice gets turned directly to gas, which creates some amount of thrust.
Yep.
So basically, as it's moving away from the sun, it's not slowing down as much as we think it would slow down.
Yes.
It seems to be having some sort of additional thrust. So off-gassing, as it sounds, puts off gas. We observed it. We didn't see any gas being put off.
And yet, we are seeing it accelerate away from us as it appears to be on course to leave our solar system.
Yeah.
Which, okay, let's just stop there for a hot second.
Sure.
And say, what the fuck then?
Yeah. Yeah.
I mean, I think we're going to talk about a handful of other reasons, but I am a dumbass, but I also don't have any actual, no one has been able to say to me why that makes sense or why that's yeah, probably.
Yeah. Part of the problem with a lot of this stuff is that we're relying on a very limited amount of observations.
Yes.
And under less than ideal circumstances.
Yes.
So the first thought was it's a comet and the acceleration is due to off-gassing.
Right.
It doesn't seem totally impossible to me that if you have limited observation time at a distance that's pretty big and becoming bigger,
right,
that you might not be able to see off-gassing happening, even if it is or was happening.
But go ahead.
What's maybe weirder to me is that if it's a comet, it's not giving off gas, and it's much more reflective than any other comet we've observed.
Right.
So it has 2 pretty distinct non-comet traits.
Yep.
Most comets reflect about 4% of the light that hits it, and Oumuamua was reflecting about 10. So
more than double what we're used to.
Significantly more than like what is the normal range of comets we've observed.
So that's another really weird part, is the light reflection element, which, as far as I was able to discover, has led some scientists and researchers to say that its composition may very well be not natural in origin. Because if traditionally...
Not natural meaning what exactly?
Manufactured in some way.
Okay.
Because if we're used to seeing an average of 4% of light reflected, but it's more than double that, what would account for what it's actually made of to reflect light like that?
I kept coming back to, while I was reading through all this stuff, all of our comets usually do this information is based on comets that have originated in our solar system.
Sure.
And this being the first time that we've observed something that appears to have originated outside of our solar system, we don't necessarily know how those objects act.
Right.
Because we have nothing to compare it to. We have a sample size of 1 in this case.
Right.
So maybe, and I don't know enough to know how reasonable this is, but could it be that whatever solar system this thing originated from, comets are more reflective for some reason, or comets off gas differently, or
sure,
in a different spectrum or something than we're used to observing in our solar system?
Sure.
I don't know. I don't think it necessarily, I think it's still a bit of a leap to go to, well, therefore someone made this thing.
No, I think that's fair. I think those are fair assessments.
Because it is, for the most part, just interacting with us, with our sun, as a totally dead object. Mm-hmm. It doesn't appear to be under any sort of control. It's not changed its course.
Yeah.
It's just accelerating slightly more than, accelerating slightly more than we would expect it to.
Yes.
If it were an asteroid.
Yes.
It's not like it came through and then like stopped and took a left.
Sure. Sure.
It doesn't appear to be propelled by anything unnatural, so to speak, or mechanical.
Sure.
It's also a really fucking weird shape.
Yeah. So the
cigar shaped, if you will.
They often say cigar shaped. Not saying it was aliens.
Well,
but
God damn!
So there's an artist rendition of this thing that helps you understand the kind of proportions that we're talking about with the 2,600 feet to 260-ish feet around in diameter. But the thing that's weird about this is through our observation, we don't have a lot of things that take this kind of shape in space. If you look at planets, our planets are round because over time, the way that things, both through gravity and through the way that things sort of, I don't know what the right word is, like dissipate in our universe.
You run into stuff. You get your edges rounded off usually.
Right, yeah.
Especially if you're coming from, you would think even more so if you're coming from outside of the solar system. That means that thing is pretty old and it's traveled a long way and probably hit a bunch of stuff.
Yeah, and also too, just from what we know about physics, like something that's tumbling like that and is that long, it doesn't behoove itself to continue doing that without breaking in the middle at some point or having breakages.
Yeah.
It just, from what we understand to be the laws of physics, something can't just continue to hurtle like that without eventually having a breakage. Is that the same in space? I feel like that was the way I understood it, was that that's what happens with breakages over time, is like it's both breaking internally, but also the edges get rounded off as it runs into shit too.
Are you saying its own like centrifugal force would pull it apart at some point?
Yes.
Okay.
At the dead center.
Because that Harvard paper we're going to get to later did the math in a way that I certainly cannot do the math and determined that it would not necessarily break apart from its own forces.
All right.
Or other gravitational forces.
Word.
But it also depends on how dense it is, which we don't really know.
Sure. Okay, so if it potentially were made of the right composition of things, centrifugal force would rip it in half. But also...
Maybe, yeah. It's hard to say with the observations that we've had so far.
Okay.
What we do know is that if those observations are correct and it is at a 10-to-1 length to height ratio,
we ain't seen it.
That is, quote, an unprecedented value for previously known asteroids and comets in the solar system. That is a quote from Karen J. Meech, who is an astronomer at the University of Hawaii and has directly observed the Oumuamua.
So, just to clarify.
Usually, just one more thing about that. Usually 4-to-1 or 5-to-1 is about the top end of what we observe in asteroids and comets. And this is twice that.
Got it. So we've got the speed, an unprecedented speed, speeding up as it goes away. We've got...
not decelerating as much as we'd expect it to.
Okay. That one.
I don't, again, physics and...
I'm a dumbass.
Yeah. I am too. Y'all are going to be yelling at your phones a little bit.
It's not so much speeding up as it's not slowing down as much as it would.
Sure.
Just by gravity.
I'll say it's the speed of the object, just in general.
Yeah, sure. Yeah.
The light reflection of the object.
Yes.
The shape of the object.
Yes.
Are all, as far as we're aware, unprecedented.
Yeah. I think that's fair. Also from Karen J. Meech, she did a pretty cool TED Talk about this object recently.
Oh, what?
Yeah, we can link to it. Hearing for 15 minutes or so from one of the people who actually observed and has written about this and works at the university and observatory where it was discovered is pretty cool. Yeah. Towards the end of that TED Talk, she says, quote, "We believe it's a natural object, but we can't actually prove it isn't something artificial." Which might be a good time to transition to this Harvard paper that came out recently and put this whole thing back in the news.
Yes. I guess I want to ask one question about that statement before we transition.
Mm-hmm.
How often can we? Do you know what I mean by that? Like,
yeah, proving something isn't something, I guess, is sort of a tough position.
Yeah.
I think what she's saying is, if it were some sort of artificial structure, we just haven't been able to observe the things we would need to observe to make that conclusion.
Okay.
So I think she's saying, like, we don't really have any reason to believe it is, but I guess based on our limited observation, we can't say conclusively it is not.
Yeah.
I don't exactly know what she means by that, but it's provocative. Gets the people going. Wasn't there, before we get into this paper, wasn't there one more element of the, of Oumuamua that had to do with, like, its temperature? Not that I'm aware of, but maybe.
I thought there had to do something with the whole, like, the combustion elements of it. Like, if it were breaking down as it was traveling, it would be giving off a thermal reading. And for some reason, this one wasn't giving off the type of thermal reading we'd expect from, like, a comet or an
associated
asteroid.
with said off-gassing?
Yeah.
I don't know. I did not encounter that.
Okay. I thought I read something about that, too, that was like they didn't get a temperature reading that they would have expected, which also made people wonder, A, what it's made of, and B, how it's moving as fast as it's moving.
Gotcha. So this Harvard paper that has been all up in the news in the last week or two is titled, "Could Solar Radiation Pressure Explain Oumuamua's Peculiar Acceleration?" It was written by Shmuel Bialy and Abraham Loeb. So I read through this whole thing earlier today, and it's pretty dense in terms of, like, they lay out all of their work mathematically, and I can't keep up. But
that looks like an equation. Skip.
Yeah, I went through and tried to sort of assemble their conclusions or their what they were testing and what they think might be happening sections.
Sure.
So,
sorry, can I interject one quick
thing?
Absolutely. If the fact that these two gentlemen, Shmuel, that's a gentleman, right?
Correct.
Okay. These two gentlemen are, between the two of them, professor and chairs of astronomy and postdoctoral scholars at the Harvard-Smithsonian Center for Astrophysics. If you're not impressed by just that, I think it's also worth noting that Abraham Loeb has published 4 books and over 700 papers on topics like black holes, the future of the universe, and the search for extraterrestrial life. So, like...
Yes, or yes, but...
Sure.
This article has not yet been peer-reviewed.
Yes.
And Loeb
is... The paper.
Yeah.
Yeah.
Loeb is also the chair of something called the Breakthrough Starshot Initiative at Harvard. And their goal, and they have $100 million of funding to do this, is to demonstrate proof of concept for interstellar extraterrestrial drones.
Look, if it's good enough for Harvard, man, it's good enough for me.
Yes, but in this paper that we're about to get into, there are some conclusions that may be slightly biased. Or one could potentially read as biased based
towards that goal.
Yes.
Sure.
Yes.
Okay. That's fair. I guess the only thing I wanted to point out is these aren't a couple of yahoos or a couple of like 20-year-old science kids who wrote a paper. This is like people who are relatively developed in their professions.
They've been doing physics at Harvard.
Right.
Yeah.
Right. And they may have some ulterior and additional purposes for saying some things we don't know, but
yeah.
Generally speaking.
Okay. To the paper.
How many pages was this? You read the whole thing?
It was only like 6 or something. It wasn't that long.
Damn.
Yeah.
All right.
I've read 6 whole pages, bro.
I was like,
I skipped all the parts that had numbers in it.
I was like, I read 6 whole articles. I did not read 6 whole pages.
Okay. It starts out with, in this letter, we explore the possibility of Oumuamua being a thin object accelerated by solar radiation pressure. That being, the sun gives off radiation. I don't really know how photons and particles and waves and all that stuff works.
But I'm going to catch it.
But when Ryan walked into the studio, I had a YouTube video up from which I found after searching, how do solar sails work?
You guys, what I really want more than anything is for us to get to a point where we have a quote-unquote television show where Spencer and I are just in front of a green screen and we say fucking wild shit in front of a green screen.
So I think, as far as I understand, the basic concept of something being, quote, accelerated by solar radiation pressure is that solar radiation energy from the sun can actually exert a force onto something.
Sure.
And that force can or has been used to accelerate objects.
Sure.
Japan successfully launched a probe called Icarus. I don't know, recently. That operates on this principle. It's basically a big sail that the sun pushes in a direction.
Yes.
So they're exploring in this article the
2010.
Okay. Recently.
Sorry.
Quote unquote.
Well, depending on your timeline, that is as recent as it needs to be.
They're exploring the possibility that this object could be moving based on that same principle. That the acceleration discrepancy we're seeing could be based on solar radiation. They go on to say that for radiation pressure to be effective, the mass to area ratio must be very small, meaning that something has to have a huge area to catch radiation, so to speak, and the mass of the object has to be extremely small because it doesn't exert a lot of force, so you need to maximize how much of the radiation you're catching and how little mass you need to actually move.
So it's got to be big, but it's got to be light.
Yes. So for this...
I'm fucking killing it, man. I'll teach this class. Give me a TED Talk. Give me a TED Talk. Okay, so it's a cigar and it looks weird, but it might be real big and real light at the same time.
That's an idea.
And it's probably got aliens in it, okay? Give me some dollars, thank you.
So they concluded that in order for this to work for the size of Oumuamua, it would need to be extremely, extremely thin. So if this thing is actually 2,600 feet by 260 feet, it would need to be somewhere in the range of 0.3 to 0.9 millimeters thick.
So
we're talking about like the whole thing would need to be basically a sheet of tinfoil.
We're speculating that this a hull of a manufactured alien vessel.
Correct. If it just were a thing.
Yeah.
They're not saying like there are naturally occurring thin things. They're not saying at this point it's an alien spaceship. They're just saying, could this be the principle that's happening here? And if so, what would this material or what would this object need to actually look like or be made of?
To account for the speeds that we're seeing it move at, etc.
Correct. So technically possible. This thing could be really thin, maybe. So then they move on to, well, if it's this thin, could it actually have gotten here from outside of our solar system? Or would it have been destroyed along the way, basically?
Sure.
And could it be moving at the speeds that we're observing it to be moving at?
Which is like my first question, too, is if it needs to be that thin, to be that light, to move that quick, can that material that is that thin be strong enough to move at that speed?
Well, don't worry. Shmuel and Abraham did the math for you.
Thanks, guys.
Because we would never, ever get there on our own.
Oh, my God. No.
So I just basically copied and pasted the sentences I could understand from this article.
Sick.
Next, we explore the implications of impacts with interstellar dust grains and gas particles in terms of momentum and energy transfer. So they're saying, would this thing impact enough space dust and other like gas particles, anything with mass, to counteract any momentum gained from solar energy? Still with me? You're making faces like your brain hurts.
Oh, it hurt my head.
So I
tried really hard to follow that, and it just fell apart.
Okay. So space is not completely empty, right?
Right.
There's some like dust and stuff out there, and there are gas particles sometimes.
Yes.
As this thing is moving millions of miles through space, it's running into those, right? So they're saying, would the stuff that it's running into slow it down enough?
Got it.
So that we wouldn't see the speed and trajectory that we're seeing.
It's like drag.
Yeah. Yes.
Sick.
Except it's not air, it's other stuff.
Right. It's the particulate in space.
Yes.
Got it.
Couple pages of math later, there's another sentence I could understand.
Flip.
And that sentence says, evidently, Oumuamua can travel galactic distances before encountering appreciable slowdown. So they did a bunch of math based on the known amount and density of gas particles and dust particles and stuff in space versus how much momentum this thing would be getting from solar particles, and said it could travel literally across the galaxy before it would start slowing down from running into stuff.
Got it.
Their conclusion was, quote, for our constrained value for the mass to area ratio, Oumuamua can travel through the entire galaxy before a significant fraction of it, before encountering appreciable slowdown.
Got it.
Okay. So they also, it's not just that it would slow you down, right? They want to try and determine if something that thin could encounter all these particles without actually breaking apart.
Yeah.
So if these particles put a bunch of tiny little holes in your sail, now you're not receiving as much momentum from solar particles because they're going through you.
You're too Deckard.
Whole program is cocked.
Severely cocked.
A couple more pages of math later, these guys said Oumuamua can travel through the entire galaxy before a significant fraction of its mass would be evaporated.
Okay.
One thing that I did not consider that they did consider because they are Harvard physicists is that most often if it encountered something, it would be moving at such a speed that it would not it would basically make a tiny little hole in it by melting whatever substance this thing were made out of. And that would fuse back together before it encountered another thing. So it would like temporarily make a tiny, tiny little hole in something that would essentially repair itself like almost immediately.
That sounds efficient as shit.
Physics be doing stuff, man.
Physics be doing stuff.
Space be full of mysteries.
I guess
sometimes it be like that.
You don't think it'd be like that, but it do. I think I think it would have to stand to reason that this thing moving so fast from outside of our galaxy into our galaxy and through our galaxy, for it to not break apart, it would have to be doing some sort of like, it's essentially like regenerative in a way, that it's receiving it's receiving detriment to its structural well-being, but also self-repairing against that detriment so that it can continue going on from before it entered our galaxy and beyond.
I think also more of space than we realize just doesn't really have shit in it.
Yeah.
You're just going through
blank canvas.
Literally nothing for a lot of that time.
Sure.
Another thing that they explored is basically, would this thing rip apart? Either from its own forces or from tidal or gravity, forces of gravity from other bodies.
Yeah.
To see if its, quote, tensile strength is sufficiently strong.
Sure.
So
that's a word I remember from 11th grade
I've
physics.
heard it before, I think. Yeah.
I think they use tensile strength when they talk about like the surface of a bubble of water, don't they?
Honestly, when I read that word, I was like, tensile. That sounds like hensile, prehensile. Those are tails. I thought about monkeys.
Wow.
And then I had to like do a quick
I'm a dumbass.
and reread the word and start thinking about space again, because I was on New World Monkeys in about a second and a half.
Tensile, they use that when they talk about like the surface tension of a droplet of water is actually partially what makes it a droplet instead of it like basically falling apart into smaller droplets of water or just splashing.
Yeah. Tension.
That's
a word I know.
Somebody smarter than me listened to that just now and they were like, kind of. Like it probably wasn't like that was real stupid, but it was like, nah, all right.
Well, look, if you're not prepared to do the research.
I haven't heard that one in a hot second.
So, again, a couple pages of math later, they said, quote, Oumuamua can easily withstand its own centrifugal force, so it's not going to rip itself apart.
Okay.
And unless Oumuamua encountered an extremely close approach to a star in its past, it is unlikely that tidal forces would play any significant role. So unless it got real close to something with a shitload of mass like a star, it probably would not be ripped apart.
That sounds hard to believe based on the supposition that this thing is like the shell of this thing is a millimeter thick.
What does? That it wouldn't be ripped apart?
Yeah. It's real big. If a real big thing was that thin, it just seems unlikely that moving at that high of speeds that it wouldn't fold in on itself.
Yeah, I think I don't know anything about science, but for me, it's hard to imagine what something moving at that speed, A, just in general, is like.
Yeah.
And B, what moving at that speed through a vacuum that's mostly
it's true.
That's unpopulated.
True. I was making dumb statements about it tearing itself in half earlier because I was thinking about like Earth physics, wherein there are like things like drag and things like that make things tear apart. Whereas from a vacuum physics perspective, yeah, that's a completely different ball game.
Right? Maybe?
Yes. I'm going to go with yes because there's no one here other than you and I to correct each other. And that sounds like
this is going to be a week where we get a lot of emails, isn't it?
Oh, yeah.
Right.
But you know what, though? Do you know what, though? Hi at whatifpodcast.com.
No, I welcome them. Yeah.
You guys are always nice about it. You're like, hey, you guys did, here's your B- or your C+, or oops, you got an F. And here's why. But you guys are always nice about it. It's just that some of you are, most of you, probably all of you, are significantly smarter than we are. So you got the fix for us.
Remember way back in the day when we did that like audience survey thing to find out our show demographics and such? I
do.
And it was something like 8% of our listeners had PhDs.
Yeah.
I'm sorry.
Yeah.
If that's still roughly I'm sure we've attracted more dumb people the longer we've gone on.
Makes sense to me.
Those 8% are probably long gone.
No.
But if you're here, we're sorry, and we welcome corrections and criticism.
Yeah, I also think there's a distinct chance that the bigger we've gotten, the more helpful emails we get, and maybe it's people who gravitate to the show and they're like, oh, those poor things. And then they send us nice corrective emails. And that's why I believe that actually everyone who listens to the show is smarter than us.
It could be.
And they're like, they're trying and I love them because they're trying. Oh, cute.
Bless their heart.
Oh, you cute little sweary boys. You're trying. And that's what we love about you.
Listen, you wee bastards.
I did kind of almost slip into an Irish there for a second, didn't I? Oh, he's got a small brain, but we love him for it anyway.
Anyway, their conclusion towards the end. Well, they have many conclusions.
How many?
So they start out by saying that this scenario of this being an extremely thin object could accurately explain the weird acceleration that we've observed of Oumuamua.
Okay.
So following this hypothetical scenario a step further, if it is an extremely thin object with this severe mass to area ratio, what is it?
Fucking A, crowbar.
Because we don't have any, the actual images, like photographs that we have of this thing are essentially a dot. We were not able to image it with much resolution at all, partially because of the speed it was moving at, partially because of the distance, and then partially because of the very limited warning that we had that this thing was going to be visible and observable. So what the fuck is this thing? Is basically their next question.
Fucking A, crowbar. Which, like, I like the, I think we need more people that are like, look, the shit's weird, so let's talk about it. What the fuck is it? Like, we don't say we know, but we're not saying we're not going to at least, like, throw a fucking stab out there into what it could be.
On principle, I really respect the informed but speculative nature of this paper.
Yeah.
Whether or not it is appropriate for wherever they're publishing it, or whether or not their peers look at it and say, yeah, go for it. We agree, or we think you did this correctly. I always like seeing really smart people speculating, and really informed people speculating about stuff in their own field.
Sure.
And like,
because they're the ones who are qualified. They've walked to the edge of their education, and they've walked to the edge of their, the structures and the processes and the research and the data and the information. They've gone all the way to the edge of that. So they're the ones who, if they're gonna go, about something, they're the most qualified to say some shit that is bona fide. I don't fucking know, but if I were to think about it in this way, here's how or what I would think about.
And it also sparks conversation within their field and within the public. Of
totally.
Other scientists have already reacted to this or been asked to comment on this and say, no, I think that's nonsense, or maybe there's something to that, or I think this part of their process was right, but I think their speculation is off base, whatever.
Right. Well, and for what it's worth, sorry, just to jump in quick, I think that exactly what you're talking about right now is a big part of why this whole story came back into the news.
Oh, this is the reason why it's back in the news.
There was some declarative speculation made at the end of this paper that made everybody go,
right.
Let's talk about it,
And
which is great. Like, I think at the end of the day, that is like good and fun and healthy. And to be honest, I remember reading something, I don't know, 3, maybe 4 months after the initial Oumuamua article came out, after the whole initial kind of buzz wore off. And maybe we even talked about this on the page show. I don't remember. We might have also talked about it at a basketball game over a beer or something. But I remember somebody saying, I think it was actually a Reddit comment or something like that, where someone said, I work in the field and this topic is like dividing the most intelligent people who work in this field that I know. Like, there are career astrophysicists and fucking like crazy smart people who work in these fields who are at odds with each other about the hypotheticals of what this thing is. And that alone to me is fucking awesome.
Yeah,
like that's
a thing
sick.
Worth talking about. Then.
Totally.
Yeah. So I'm just going to kind of read through their summary section because it's mostly in plain English and I think most of it's interesting. So they start out by saying for known solar system objects like asteroids or comets, they all have mass to area ratios orders of magnitude larger than our estimate for Oumuamua. So they're saying no known comets or asteroids have a composition anywhere close to what we're suggesting in this article.
Got it.
So saying if this thing is 3 millimeter or 0.3 millimeters thick, it's not a comet or an asteroid.
Yeah.
They then say if radiation pressure is the accelerating force, then Oumuamua represents a new class of thin interstellar material, either produced naturally through a yet unknown process or of an artificial origin.
Heyo!
So they're saying if this thing we just described for the last 6 pages is accurate,
which accounts for what we've observed in it,
and the math appears to work out if we plug in this thickness,
right?
This would be a totally new thing. We have not observed anything like this.
Yes.
Now it starts getting weird because the next paragraph starts with considering an artificial origin.
Whoop, whoop.
One possibility is that Oumuamua is a light sail floating in interstellar space as debris from an advanced technological equipment. So basically saying this was part of something else that was either intentionally discarded or broke apart and is now acting as a light sail. Light sails with similar dimensions have been designed and constructed by our own civilization, including the Icarus project and the Starshot Initiative, which is his own fucking project.
Self shout out.
Mm-hmm. The light sail technology might be abundantly used for transportation of cargo between planets or stars. And in the former case, meaning that this is just floating, ejection from a planetary system could result in space debris of equipment that is no longer operational and is floating at the speed of stars relative to each other in the solar neighborhood, which is a concept I don't really understand.
But
so
it
I'm not going to guess
sounds
about.
Very like fun. Won't you be my neighbor?
I think what he's saying is that, whatever, never mind. I don't know. I was going to guess and I would probably be wrong. So we'll let someone else Google it.
I mean, it just seems like it would be like, adjacent system, right?
Sure, maybe.
All right.
They go on to say this would account for the various anomalies of Oumuamua, such as the unusual geometry that was inferred from its light curve, meaning the way light reflects off of it.
Yep.
Its low thermal emission, which I think is what you were getting at earlier.
I read something about that it's like, it's not as hot as it should be for how big it is and how fast it's moving and shit.
Its high reflectivity and its deviation from a Keplerian orbit without any sign of a cometary tail. So saying that this thing is not in the normal orbit of an asteroid, yet it does not appear to be a comet.
Man, I love this shit.
Well, let me get through some more of this.
Go ahead.
Okay. Although Oumuamua has a red surface color similar to organic-rich surfaces of solar system comets and asteroids, this does not contradict an artificial scenario, since regardless of the object's composition, as it travels through space, its surface will be covered by a layer of interstellar dust, which itself is composed of organic-rich materials.
Yes.
So they're basically saying this thing has a red surface, which usually means organic. But they're saying if this thing traveled the distances that it appears to have traveled, it would have
covered in red shit anyway.
Organic material on its surface anyway.
Right.
Alternatively, a more exotic scenario is that Oumuamua may be a fully operational probe sent intentionally to Earth by an alien civilization.
Let's go! Let's go, baby!
It's lit.
Based on observation and assuming natural origins following random trajectories, the number density of Oumuamua-like objects should be extremely high, equivalent to 1,015 ejected per star. Meaning, if things like this existed naturally, we should be seeing them all the time. There should be thousands of them coming through our solar system, and we've seen one.
Yeah.
Suggesting or maybe implying that these things either aren't occurring naturally all over our galaxy.
Yes.
Or that we're really bad at looking for them.
I took a breath and I looked at you like I was about to say something, and then I was like, should I wait to say it?
Okay. This discrepancy is solved if Oumuamua does not follow a random trajectory, but rather is a targeted probe. Interestingly, Oumuamua's entry velocity is found to be extremely close to the velocity of the local standard of rest. They lost me. Lastly, since it is too late to image Oumuamua with existing telescopes or chase it with chemical propulsion rockets, it is likely origin and mechanical properties could only be deciphered by searching for other objects of its type in the future.
As in, like, we're going to have to see this again.
And there's, right, he's saying we would have to observe that our best bet of figuring out what this was to find something like it again. And they're also suggesting that if this is a natural object that we saw, there should be thousands of them that we can observe in the future.
Right.
The last thing that they put in here is that Oumuamua was found not to show any radio emission down to a fraction of the power of a cell phone transmission.
Wait, say that one more time?
Oumuamua was found not to show any radio emission down to a fraction of the power of a cell phone transmission. So scientists thought that this thing might be a probe of some kind or an artificially manufactured thing of some kind. And if they checked to see if it was emitting any radio frequencies, and it was not.
Got it. But
lastly, they say a survey for light sails as techno-signatures in the solar system is warranted, irrespective of whether Oumuamua is one of them.
So
which could be read as either a plug for his $100 million project, or saying this might be a good way to figure out if aliens are coming to say hi.
Yeah.
You have things you want to say.
I'm processing on this whole thing. I've been processing it since it came out. We've talked about it. I've thought about it more, and I did a lot more processing in the last, 72 hours prepping for this episode. And when you said there should be thousands of these, one of the things I was worried about, because you said there should be thousands of these, or we're really bad at looking for them.
Well,
and I've thought,
potentially, yeah.
But I've thought perpetually about how bad we are at looking for stuff.
Yeah, I think that's a pretty likely explanation.
Yeah, in fact, I can't remember what. There's a great new series on Netflix called Explained. It's called Explained, I think. It's a Vox Media series that they're doing, and they're like 15 to 20 minute mini documentaries about everything from the sport of cricket to tattoos to gender equality to they're fascinating. They're really cool little like mini documentaries. But one of them was on the search for extraterrestrial life, and one of the people who was interviewed on it said something to the effect of, if you take into consideration the amount of time and actual like space that we are able to pinpoint telescopes into space with on our planet right now, the equivalent of what we've looked at from like a peering into our universe perspective is a glass of water in comparison to the oceans of our planet.
Right. Well, shit, we haven't even figured out what's in our oceans.
Honestly, like real shit though. Like we don't even know it's here. And what we've looked at outside of here is so minimal. I mean, like, I think even the Hawaiian observatory that caught this thing was like, it was kind of crazy that we caught this thing. Like we just saw this weird flash of light that was different than something we'd seen, and we honed in on it, and then so did some other people, and then we got the data that we got, and isn't this thing crazy? But this is my quiet confliction as I'm like processing, because just because there may be more of these, though, doesn't necessarily remove the possibility that these are something artificial, that they are not just organic byproducts of our universe.
Well, no, but you could also say that about asteroids or comets then.
Well, yes and no. I mean,
the steps would be, let's observe more of them and figure out how they're operating.
Completely. But I guess my question would be, with all of the comets and asteroids we have observed by looking at that glass of water, why are these more rare? And what about them is more rare? And
because comets and asteroids exist in our own solar system, so it's much easier to look at them and track them and figure out their orbits and all that fun stuff.
Totally. But I guess it still means that the rarity of these objects passing through our solar system, they are potentially significantly more rare, if not slightly more rare, because we continue to look at that glass of water sized sort of, chunk of space.
Well, right. Yeah. We're not going to see the rare things ever very often, if ever, if we're only observing little tiny pockets.
Totally.
Once in a while.
So that's like the counterbalance in my head is like, well, yeah, there could be more of these, but that wouldn't necessarily mean that this couldn't be artificial in origin, or it couldn't be.
Sure. Yeah. We still, right now, we don't know what it is, whether there's one of them or
thousands of them,
millions of them. Yeah.
So either way, it's still.
But if we observe millions of them, then we'll probably figure out what they are.
Well, right. We need one to come closer to us. Although not too much closer, because one of the articles I was reading was if that thing had kept on, not on its trajectory, but like if a thing like that had come directly at us, it would have been super bad.
Can I leave you with one quote from...
Leave? Are we done already?
We're over an hour, bud.
God damn! I thought we had like 30 minutes left. I was ready to talk about all kinds of other shit.
Well, save it, bud.
I guess we'll save it.
Can I leave you with one above top secret forum quote?
Wait. We can't leave on an above top secret quote.
Of course we can.
Okay, we can, but first I need to know your take. Like, what's your take?
I think it's a weird, far away asteroid that we haven't seen before, and there's probably a bunch of them, but we haven't seen them.
Man, for a dude that wants to be abducted by aliens so much.
I mean, when nothing about this says aliens or intelligence or anything other than like, oh, that one's weird.
Yeah.
I mean, if it stopped and turned around and it was blasting radio frequencies, I would think it's probably aliens, but it just, it's a weird rock.
Yeah.
Space is real big. There's probably all kinds of weird shit out there that we don't get to see.
It's like the oceans.
Yes.
there's a lot of weird shit that we just continue being like, oh yeah, I guess that's a species we've never seen before.
I've only seen like, less than 1% of all the fish that are on Earth probably.
You mean like in totality or like types?
I meant species.
Yeah, got it.
Yeah.
I was like, yeah, you only eat fish for dinner like once a month. You
Those
probably
don't
have
count.
definitely seen less than
Those came
1%.
from farms probably anyway.
Well, there's that. All right. That take makes me sad because I wanted you to be. I wanted you. I wanted you to want it, Spence.
I was about to read someone else's take that I think will make you very happy.
It's aliens. Okay. All right. I want to hear it. Above top secret. Show me what you got.
When most people think of a space probe visiting us, they think of a technological device. Why not just embed it within an asteroid? I bet you that shit was the alien version of a spy satellite.
That's real.
Boom. Hot, stupid take for you.
But also,
what? But also what?
A weather balloon crashed. Yeah, was it a weather balloon that also had a spy satellite in it? Because maybe.
Was it a weather balloon full of little aliens?
Was it a Trojan horse? Yes.
Ryan, can I read 2 more hot above top secret takes for you?
I'd honestly love it if you did.
Has anyone thought that this could have been Nibiru / Planet X, which has been discussed so many times?
No.
I know it's supposed to be a planet, but maybe the people back then thought to describe it as a planet and maybe was a lot larger in size, but since has had chunks of it broken off. Says a guy who has no idea how big planets are.
Down to the point of it being a couple 100 feet across?
Apparently.
That planet would take a long time.
Last hot take. I bet it's a broken chunk of a Dyson grid. That's been my suggestion since it was first detected.
I'm sorry, a Dyson grid?
I think he's talking about the hypothetical thing that you can build around a star in order to harness all of a star's energy for your civilization. The thing that people were suggesting the alien megastructure bit was. Remember that from like a year or 2 ago?
Yes, I do.
Basically, you surround your whole star with solar panels.
Sure.
And then you take all the energy and funnel it back into your business.
Look, I'm going to be honest with you.
And a piece broke off and went to a different solar system, I guess, this guy's saying.
I'm going to be honest with you, and this is going to let us leave on our favorite new button from today. When you read that, I thought that I don't have enough money to own a Dyson vacuum of any kind. And I was sure that a Dyson grid was like a hot new piece of Dyson vacuum
like a
technology.
Series of Roombas. Mm-hmm. That like just they divide your home into a grid and
We go clean up space with a Dyson vacuum. Sometimes that shit's gonna break, but then we'll just vacuum up the broken shit too.
That's an idea.
Hey, thank y'all for supporting the show. Thanks to the new Patreon listeners. Like we said, if you want double the What If Podcast, go to patreon.com/What If Podcast and get 2 episodes a week, every single week for just $5 a month. Also, we didn't play any voicemails this week, but if you want to leave us one, we might play it next week at 612-246-4614 to leave one of those. And if you want to send us an email, you can always do that at hi@whatifpodcast.com. Also, we got 2 quick announcements.
Oh, shit.
You go first.
Nope, you should.
Okay. My quick announcement is if you are listening to this Tuesday, the day that this comes out, and you live in the Twin Cities area, I am going to be hosting a book release show at Amsterdam Bar and Hall in downtown St. Paul.
Let's go heckle Ryan. Let's go heckle Ryan.
If y'all want to do an unofficial fan meetup and or heckle me while I host a poetry and music show in downtown St. Paul, you're more than welcome to do that. It's at Amsterdam. It is the book release for Shane Hawley's ABC Death, which is his kids/adult book being released on Button Poetry. So yeah, come on. It'll be fun. It's 7:00 and tickets are cheap and it's going to be a bunch of great art there that night.
Sick. Last thing, friend of the podcast, all around great human being, Lydia Liza, and I have a new song that we're putting out today if you're listening to this on Tuesday, and it sounds like this. Love you guys.